So last week we have learned about the use of energy method. Okay. So to obtain the same trust element. Okay. One of the good purpose there is by using the energy method, okay, you are able to handle distributed displacement. Okay. So you are no more assuming only two ion displacement. You are able to do the interpolation of displacement between the two ends. Okay. So then this gives rise to the okay. First we are able to lump the distributed forces onto the two ends of the element. So this is what we have obtained last week. Okay. But to be honest, when you are doing the solution for this, okay, you do need to do the memorizations of the derivations. Okay, you just have to know how are you going to do the application. So for all the elements, you need the end force. Okay, so that's why in the coming homework, let me show you. Your homework 2. In the case of homework 2, you have to apply the energy method, okay, to find out what is the equivalent force. Okay, for example, you might have a bar, but this bar is subjected to increases the increased forces or increased stress. So the stress was 0 on the angle of the cantilever, but the stress was maximum at the end. So in this case, how could you model this bar element and find out the model force? Because remember, your finite element cannot handle the internal force. Okay. For example, this. Take for example, if you are having distributed force along the element, okay, what are the equivalent model force? If you use the energy method, you can find the work done by the distributed force is equal to the displacement at any point and the force at any point, and then divided by the total length. Okay. So anyway, so the normal force is force density, or so-called the force per unit length times the length over 2. So you are lumping the uniform distributed force on the left node to be half of the total force, on the right node to be half of the total force. This was the uniform loading. Okay. In the homework here, you're going to handle non-uniform force distribution. The force is increasing, but how much is the force on the left-hand side and how much is the force on the right-hand side? Is it going to be 0? Not necessarily. Is it going to be total force, which is force density times the length, basically 80x, and then you do the square root. Okay, you do the integration along the length. Okay. It is this total force is the triangle. Okay. So are you going to get that? To all run onto the end? No. So you've got to do the energy method, calculate the work done by the force. Okay, on each segment. After doing the integration, you could probably find it. And also, last week we teach you about the thermally induced force. Okay. So we have covered that part. So let me show you. We're still using the energy method because of the ease of understanding. Okay. important here? The important here is, okay, first you have to understand what is thermal induced displacement. There is a rod, you pull it by force, okay? You can do extension. Alternatively, you can heat it up without any forces applied, it will expand, okay? So if you look at the Hooke's law, the Hooke's law that you normally see at the cold temperature or room temperature is this blue line. When you are doing the pulling, then it elongates. What is the effect of heating on the leg? The heating will cause the static thermal-induced elongation. So the starting point where you apply zero force will have the length increase due to the thermal expansion. So this is the effect. And then in terms of the force-induced elongation, the more the force you apply, the more the elongation is. It still follows the same Hooke's law. Okay? So whether you are talking about a hot spring or you are talking about a cold spring, so they still present you the same elongation under the pulling force. So this is the understanding of the two the forces. Okay, now next, there is another understanding. How do you calculate the thermally induced expansion? Okay, so you might not thought any forces is needed to cause the thermal expansion. That's true. But if you now block the rod by tapping on the two ends, if you hit the rod, then something happens. The rods are not free to expand. So in the end, the rod will be subjected to compression. Okay? So this leads us to the understanding that if you block the heated rod, you will induce thermally induced force. This block force is the stiffness times the free thermal expansion. Okay? So in a way, if you now want to calculate the thermally induced elongations, you can say, oh, my thermally induced elongations is caused by equivalent pulling force. So this equivalent pulling force is not the compressive thermal block force, it's now become the tension. If you now multiply the elongation times the K, then you have the equivalent thermally pulling force. Okay? So I go straight to the final derivations. Okay, you can do the calculation of the equivalent force by substituting the thermally induced strain to the energy expressions. Okay, but when you are handling the equations, okay, what is the equivalent force? Your equivalent force, which is the thermal force, let's see here. Yeah. Okay, let's take this. If I take that one, then the thermally induced elongation is caused by a pulling force. And how much is the pulling force? On the right hand side, so what do you find? Your F1 is equal to negative ND. Your F2 is equal to positive FT. So you're saying that your stiffness, you do your calculation, you might not do what you did previously. You are talking about a constant K. So this is negative K, this is positive K, and this is negative. This is a positive K. So let's have a check. If you are not familiar with the expressions, let's try this. Okay, a rock with an area A. Okay, and if the material of this E. Okay, and if you now thermally induced stress is Young modulus times thermal strength. What is thermal strength? Thermal strength is thermal expansion coefficient, okay, times the temperature rise. Okay. So if you want to find the stress, okay, you can do the substitution here. If you want to find the force, you can find the area times the thermal stress. This is EA alpha delta T. Okay. Let's look at the unit to confirm it is the force. Modulus has the unit of Newton per meter square. Area has the unit of meter square. And thermal strength has a unit of 1. So this is Newton. Okay? So you are still not sure this is the thermal induced stress. Okay, let's do the thermally induced force. Let's do another way. Thermally induced force can also be written as stiffness times thermally induced elongation. And what is thermally induced elongation? You have EA over L delta LT. Can you see this? Thermally induced elongation divided by the starting length is your thermally induced strength. Okay? 所以大部分同学可能对热膨胀不清楚，那你起码要知道，热膨胀系数基本上就是这个因为热造成的生产量除以初始长度才除以温度。OK？ 那你如果感觉不出 EA thermal strength 是一个力，那你就可以把它写成这个是压是系数，这个是静止上热造成的生产量。So this is the whole idea. Okay? But then I also need to rewrite this. So what is the purpose of rewriting this? You go to rewriting these into 2, so that you have a clearer understanding what is the physical meaning. Look at here. Your If the rod is heated up and elongated, okay, how do you find the elongation? After all, the displacement U1, you define it to be positive. This is U1. It's always toward the right. Okay. And then you U2 also moving to the right. Okay. To avoid your confusion, then I better do this. I'll draw two arrows. For the external force, I will draw them as a cold force. Okay. This cold force is always defined to be rightward positive.这门课因为是虽然是算力，但是你还是要画你的所有力，虽然都是矩阵，你在意义上你应该知道这是力。In finite element, we are very standard. All the displacement is defined to be rightward positive. On the left node, it is still the rightward U1. On the right node, it is still the rightward U2, which is positive. If you are talking about external force, it is F1 rightward positive. On the node 2, you have F2 rightward positive. Okay, these are all the external force. Then next, what happens to the thermally induced force? Okay? Because you see that the effect of elongation, okay, is part of your total displacement. Okay? This total elongation caused by the heating is rightward extension and leftward extension. So to say, you are pulled by thermally induced force on the right node. That is not cool. You are also pulled by the thermally induced force on the left node. But now it is pointed leftward. So this leftward force is negative at T. This rightward force is positive at T. So in this way, I hope you can visually see how this equation is. Okay. 所以同学看来，力学其实不难，只要你能画你的坐标，画你的位，画你的力。那大部分同学，你们以前如果是学数，把力学当数学来解，那往后会越来越为什么？你都没看过这个自己的照片，你就有一个自画像，你天天照镜子，要自画还画得出。那这个力学明明是一个几何问题，虽然我们用的工具是直率，公式去算，那你如果一开始你就不把坐标那个形状画出来，你十之八九解不了那个变换。Okay. So for this subject, what can I set the questions? Very simple. I change the angle, I change the number of rod, I change the boundary conditions. Okay? They will directly impact what you obtain as a solution. Okay? 所以你们以前学的，你如果从来不动笔，没画过，不好意思， 的考题绝对不会跟你现在看到的例子一样。你的考题可能转一个90度，转一个45度，那边界从固定到边界变成转换，然后现在还多了一个变量，我还给它加着。那你如果说你只单纯我数学公数解变项，那不好意思，你这门课这个几何只说你方向一环，那你又不考虑边界，那你得到的答案就一定是错的。对，所以你自己要去换。So next we'll see one example. This thermally induced rock force and stress. Now I have a rod, okay, of the total length L, okay, 1.22 meters. It has a cross-sectional area. It has a modulus of 206 gigapascal. You have a thermal expansion coefficient of 12.6 times 10 to the power minus 6. Would you be able to find out what is the reaction at the clamp end and the stress in the rod? Okay. In this case, I apply no external force. I just simply heat it up by 10 degrees. How much would you find the rod force? Okay. So you have to recall what we learned before. The left element has the elastic force equal to external force. What are the external force? The external force will be coming from the reaction on the left hand side. Okay, it will be coming from thermally induced force. Thermally induced force is trying to pull it apart. On the right hand toward the right, on the left hand toward the left. So now you have the thermally induced force minus Ft. This is plus Ft. And Ft as we derived just now, it is thermal Young modulus times cross-sectional area times thermal strength. Okay? And then how about the right element? You write exactly the same, except the knots are different. The middle dot is not true. The right knot is not true. So the displacement are U2, U3. Their modulus, their stiffness is not EA over L anymore. L is the total length. For element length, it is L over 2. So you have EA over L over 2. And lastly, what is the force acting on the second element? You only have the reaction force on the right hand side, F3. But because this element 2 is also subjected to heating, so together, you are subjected to a thermally induced tension. That tension is pointed toward the left of the left knot. That tension is toward the right on the right knot. So you have minus Ft plus Ft. Okay? Now, how do you find the solution? The right answer to that is force sum is by summing up all the external forces, all the thermally induced forces on the left element and on the right element. Left element associated with displacement U1, U2. So the force appear on the first degree of freedom, that is first row, and second degree of freedom, that is second row. So the third row is 0. And then second, what are the forces acting on the second element? The forces acting on the second element does not appear on the first degree of freedom. It only appears on U2 and U3. So that's why you have row 2 and row 3 being filled up by force. External force plus the thermally induced force. So on the third knot, this is F3 plus Ft. Okay, after you do the sum, you also now do the sum of the elastic, internal elastic energy. This is so-called internal spring force. That spring force is because of the identical element property. You can write EA over L over 2. This is for identical stiffness. If you are not identical, you write differently. 如果同学你如果说左右元素不一致， 那你到时候解要怎么解？那解要怎么解也很直接，你基本上就把它的这个弹性系数贴进来。If you are not given the same, if you are not given the same stiffness, then you just write them according these. Okay? There are no other simplification. Okay? 如果说你这个特别是这个是 L1， 这个也是。刚好它只是恰好相等。所以你们的作业自己要分。Okay, next. Okay. So finally, you have this kind of solution. Okay. Good thing here is the left hand side is blocked. U1 is 0 displacement. And then the right hand side is also blocked. U3 is 0. So if you now look up your equation, okay, you identify the three nodes. 那很多同学，你矩阵都写了，但是你却不去区分它的这个自由度。那什么叫自由度？We relate. Okay. 第一行 so the first row of the equations, you don't solve for that. Okay. Because your U1 is normal. How about the second row? The U2 are unknown forces. How about the third row? U3 is 0. Okay. So now you can find out, okay, if both ends are blocked, then the middle also would move. Okay, in that case, now you are ready to substitute U2, U1 into the first row of the equation to find out the reaction force. Okay. 现在要做什么？你会跑回去看第一个方程式，那是为了 find the reaction。那第二个方程式，所以学这门课到最后啊，不是在学你的数学，你是你解这些题，你是有目的性，你两边都约束。那我当然要找中间的自由点的物理。那找完你自由点的物理，那我回过头看两边，那我要找它的作用力，即便是两边都注定。So after you find the middle free displacement, you go back to the boundary where the displacement is 0. On the boundary, you are going to find the reaction. The reaction on the left node, okay, the reaction on the right node is E alpha delta T. Okay? The reaction on the left node is 0. Okay? You go and check. Is it right? Okay. Let's see. U2, U3. Okay, the first equation. I think we got typo. This is not F3, this is F1. First equation you only have F1. From the first equation, this is the axial force, the tension. Okay, next, we will still spend time to do the solution here because you might not be familiar until we spend time on this. Okay, the next question is more complex. How do you do the solution for this? Okay, I'm not going to solve the exact one, but I'm going to solve the solve this outline the method. Okay, so what is have to learn about this is the bracket that we analyzed before. Okay, but now if this bracket is not loaded, previously we learned about the loading. We talked about loading and the key. Okay, you can find how much is the displacement. If this is 1, 2, 3, then this is V2, D2, U1, V1. Here you got U3, U3. Okay? You learn this quite simple. For the first element, okay, because you clearly see that you only need to care about the stiffness. This is the horizontal one, K1, K1, K1. They only have stiffness in the U1 to U direction, F1, F2. This is the internal force, still not the local force. Okay. And then next, we read out our lecture 1. This is element 1. Okay. Then element 2. Look at the expression here. Okay, look at here. If you have an element like this, subtending an angle, you can find cosine theta to be c. You can find sine theta to be s. Your stiffness along the length cannot be given to be a global stiffness, which is K2 times C squared CS minus C squared minus CS, and then this one is the CS, S squared minus CS minus S squared, and then this one minus C squared minus CS, C squared CS, and here you have minus CS, and then S squared CS, S squared. Okay? So in that way, how to write the internal force balance? The internal force balance has to do with not displacement. Here you have displacement. Okay, I think apparently it's not equal to what we have. Okay, supposedly you have 1, 2. You have V1, V1, V2, V2. And you have the force F1, X, F1, Y, F2, X, F2, Y.所以你自己笔记要去做一下，就是说我虽然说讲义上是有写，但是那个总结你自己要去记一下。This is the inclined line. But are you going to use this one to describe the element number 2? What's the difference between the left inclined wall and the right inclined wall?左边那一边很长，这个损失。我们比较关心的是 x 轴上的转角，你的角度定义。从第一象限开始算。If you're now going to write and apply this formula, your sine and cosine is based on the angle that starts from x-axis toward the inclination. So in this case, for element 2, what is the real angle that you're going to use? It is 180 minus theta. So to apply to the same formula here, your angle is 180 minus theta. What is the sine for this angle? What is the cosine? Okay, sine is equal, cosine here is the bottom side. If you now move to here, you clearly see this is cosine 180 minus theta. Okay, this is what? This is cosine 180 is minus 1. Cosine, then you have minus cosine theta. Okay? And then, how about sine? Sine 180 is 0. So you're going to have minus cosine 180 times sine theta. This is sine theta. 如果同学这幅画分不清，你就直接画箭头。原点的左手边是第二象限，箭号末端它是负的投影在 x 轴上，它投影在 y 轴正。你学三角函数不是写公式，你是看图写公式，你不要倒过来。So for you a reminder, to many of you, if you are still stumbled on the finite element, most likely is the orientation, is the convention. Okay, so if you are writing this, the expression is the same. Okay. But your C now is going to change. So if you are using this one as the anchor, okay, your stiffness. This is the original. You do the plotting. You have now what you have? You have your C squared, then you have your C squared prime minus CS, and then minus C squared prime, then this plus CS, and then you have your minus CS. This one is still your S prime squared, this is plus CS, and then this one minus S squared, and then finally you have minus C prime squared, and then plus C prime S prime, C prime squared, minus C prime S prime, and then your plus C prime S prime minus S prime squared, minus C prime S prime, and then S prime squared. 看到没有？因为这个转角，你的仰视系数就变成这个概念。OK， 好，再下来，那我们热怎么解 ？How to solve for the heating issue? Horizontal rod, we know that is subjected to a pull by thermally induced force. So your expression here is minus Ft, and then this is plus Ft. 看到没有？那这边呢？那你如果是这样写 your Ft is always along the axis. If you are drawing this, then you have the Ft x being Ft cosine theta, and this one, vertical one, Fty is equal to Ft sine theta. 所以你力还是要懂得投影到是 x 轴跟 y 轴。And how about the left hand side? Left hand side is testing your understanding about quadrant. What quadrant is it? 来，我们看一下动作有点很好。第几象限？第四。OK。So in this case, if this is Ft, okay, it's quite difficult to argue an angle, but from your trigonometry, you know your Ftx is equal equal to ft cosine theta. And this one, fty is minus ft sine theta.那后面你们会用软件，那软件中间过程都不算。So if you are using ANSYS, the finite element software, you don't need to care about the internal calculations. They will take care for you of the thermal forces. Okay? But you still have to take care of your external forces. What is the external force applied on the free nodes? What is the external force applied on the constraint nodes? They're all going to be there. And in this case, how about the thermal force in this case? The thermal force in this case, this is a knot tool. Thermal expansion is always a pulling effect. So you can see, this is angle. So in this case, the Ft acts on the node 2 is going to be Ft cosine theta, and Ft on the node 2 in the y direction is minus Ft sine theta. How about this one? You always stick to your definition, okay? This is your third quadrant. This is the node 3. Ft on the node 3 in the x direction is minus Ft cosine theta. And then you have Ft y on the node 3 is Ft sine theta. 这是告诉同学解题技巧。那虽然我们刚才以前推了一堆，那十之八九，啊，应该是你也不用感觉得到。但考试的时候，考你的是什么？正负号判断、方向判断 ，OK， 还有尺寸判断。So what can be tested in your midterm examination? This is the part, okay? Even though we do the derivation, finally you must be able to apply what we have derived. 那同学大部分最在挣扎的就是增长张力方向，你怎么用之前的推论，好像也用不上。那真正能用得上的是还是回到最基本。So even though finite procedure is very complex, but when you are asked to do the hand solutions, it's still going to the basic. What's the basic? It is the internal force balance with the external force balance. You need to know the force direction. You need to know the displacement direction. It's back to the coordinate. Okay? 所以一般同学学了数学，学了这种模拟，你没学到的就是方向。那你如果不学会方向，相当于什么？相当于是你拿着 Google Map 从校门口到公馆怎么走 ？Google Map 可以给你图，那 Google Map 也可以给你方向的转弯。那大部分同学可能，如果说没有方向感是什么？把图拿掉，他叫你向前走100步，左转，走完后再走50步，右转，走了右转，转了右转，结果你得到是，你根本没有全景的概念。所以为什么要画图？你这个图就是你的地图。当你没有地图，只有所谓方向跟步伐，或者是数学，你这门课学了就是没有什么用处。大概就解一个规范题，不能解一些变化的。So this is important. You have to learn and master the basics and then eventually you want to apply them, okay, to your real life problem. Okay, with this, then you are able to solve your question 3.所以不要说我没学过热膨胀 ，OK？ 那热膨胀其实是等效于热造成的拉伸 ，OK？ 你看没有？这样一个题目，如果在力学上，它是不会有位移的，因为连力都没有，那是不是全部都位移都零？不是啊。然后这个题目是热膨胀。If you are now consider this force without heating, your displacement is 0. Why? There are not any forces acting on the bracket structure. Not 1, not 2, not 3. There are no external force. In response to 0 external force, there will be also 0 reaction force, and then you have 0 displacement. But in this case, the question is the structure is subjected to heating. Okay, when you heat up in daytime, when you cool down in night time, okay, all the support structure are subjected to stresses. 所以你们如果去看电子封装，电子封装是怎么会在每天开关电脑的过程中烧坏？那就是因为你开机关机，开机就烫了可以主机带，关机就回到室温，那就主机带就回到室温，这个塑料就会开始被拉伸，压缩还没事，拉伸。拉伸完，总有一天会被拉断。So in this case, how much the stress is what our concern about this pressure. Okay, you are asked to find out what is the displacement and also the axial stresses in each element. Okay, so this is the question. Okay, so far so good. Okay, then please go back and try and solve this. The next part, then we are going to study about the 3D truss. Okay, so far we have learned about the 2D truss. Okay, the 2D truss already quite handy. It's solving a bracket problem, but you realize that the real structure are 3D. Okay. So we previously thought the 3-bar truss is stable, but not to forget this can topple left and right. So the real 3D stable structure are theta 形体，它是一个四面体，那四面体 1, 2, 3 and the base. OK， 那这四面体的话。就是够气 ，OK。那最早的这个四面体，拿来做分析不错。所以 ，you know about Bell Graham, the inventor of the telephone. Okay, in their early invention, they also had a team to make the type at the time when there were no aeroplane. Okay, so this kind of kite structure is unlike the normal kite. This is extrahedral kite. Let's see the video. Okay. Connection not there. Let me go and check. So it's almost as higher than the man. Okay, it's going to go in and lift up. So how to fly the kite? First we're pulling. Okay. 所以它这个长得像这个四面体，但是只有两面有蒙皮，或两面有这个有包这个纸，所以实际上它就是像你们平常这个第一次画鸟的样子，就是像这样这一只鸟，现在它是立着。The wing blowing, then the two surface, left side and the right side of the wing. This wing is a triangular wing, can now be lifted up. So this is one of the lightest structure. How to make the kite? For this kind, okay. Even though that is negative ground with four surface, but only two of the four surfaces are covered by paper. But you now can combine them. Yes. How many tetrahedra to make a legal tetrahedron? You now have a base of 3 and the top of 1. 好，看完这个四面体，那我们现在来看一下怎么分 Let me see. Okay, before we start describing the tetrahedron, you can see how many rods do you need to define a tetrahedron? You have one surface, two surfaces, and finally a rod to combine the two. So you can see 1, 2, 3, 4, 5, 6. Altogether, you need 5 trusses. Okay? This is the 3D truss. Before we go to define all these 6 trusses, okay, we can describe one truss at a time. First, consider a truss of length L in the 3D space. Okay? The bottom point can be defined by coordinate x1, y1, z1. If you are using the distance along the x-axis from the origin, the distance along the z-axis from the origin, the distance along the y-axis from the origin, then you get the coordinate for the base. Then next, we define the tip point. What's the tip point of the 3D truss? It is located at coordinate x2, y2, and z2. Okay, after you have done definition of the 2 endpoints, one at the base and one at the tips, you can find what is the length. But Pythagoras theorem is very simple. You can find what is the distance, what is the difference along the x-axis. It is from this yellow line all the way to the blue line along the x-axis. This is the difference of y2, x2. And second, you can find out the difference along the z-axis. This is your z2 minus z1. And finally, you can find out the distance difference between the y-axis. Yeah, that is the way to define the length. 同学如果说没有感觉，来拿出你的右手，你的大拇指，你的食指，你的中指，就是标准的，这个叫正交的这个坐标。OK， 当然，拇指你可以当成是 Z， 食指可以是 X， 那中指是 Y。OK， 这是正交的一个。OK， is it defining right？ 来看一下有没有坐标定好。如果这个画错，那你到时候再去更正。OK， 这个是 X C Y。OK，so if you draw on the opposite side, use your right hand rule to do the checking. Then you will find is it right or wrong. Then next, how about the truss direction? The truss direction is to be finding the projection. 那我们先讲一下二维的投影，有同学有点感觉。How to define the projection? Okay. Here, you might have your 1 point. You might have a tip point. You have x1, y1, x2, y2. How do you find the length here? Your length is your Pythagoras theorem, x2 minus x1 squared plus y2 minus y1 squared. How do you see this? The first expression is this. This is x2, this is x1. The distance is x2 minus x1. 所以你毕达哥拉斯定律不是用写公式，是你要看着图自己去画 ，OK， 然后把画出来的东西用一个具有物理意义的东西这样明白。So what is this? This is the projection of the line to the plane. 那什么意思？相当于是太阳在正上头顶上，那如何知道我拿着一把扫把，扫把有多长 ？How long is the broomstick? You put under the light. Okay, you see, this is the projection line. Okay, what happens if I do the inclination? 这个扫把长还是短？那如何知道这个扫把很短？但是沿着太阳的方向。那如果是跟太阳方向是90度，那差不多就是它的原长。So you now know what is the projection? Okay, this is a 2D projection. This is the projections onto the x-axis. Then you know how to define this angle. Cosine theta is equal to x2 minus x1 divided by the length. Then next, how about the projection along the y-axis? This distance is what we call y2 minus y1. It is the sine theta equal to the projection on the vertical line. 这是一个2维的投影。那我们现在来看3维的投影。So you can see that the projections is to be quite different. 那我们来图的话。Okay, now how to draw the 3D one? This is the y-axis. Actually, this is y, and this is x-axis. You can define first x1, second y1. Let's see y, and then raise the start. Starting from the origin. Then you see this point here. 这是一条全长。It is this length. It is this length. And finally come to this point. is the projection to x-axis. 你如果这里打光，当你打到了光，这个投影投到哪里去了？不好意思，投到就到这里。So what's the length here? So if you are projecting to this plane, okay, then this is your y projection. Your theta y.如果不大会看，那我们大概看一下 how to do the projection. Okay. 不好意思，我这个还是从原点上看，不过我可以先从原点上看。原点上看呢，这个怎么看？所以 if you now want to do the projection, okay, I start from 0, 0, 0. Okay, if I now want to project along the x-axis, what do I see here? I see here, okay, this is my projection length. This is my x1 minus 0. Okay. Or you want to do then you cosine x. Then you have the x2 minus x1 divided by the 10. this is投影怎么看？The projection here is not projected to x c plane. It is projected this line toward the x-axis. Okay. This is what you see. The projection to the x-axis. And how much is the angle? The angle is from this line to the axis. Okay. 那同学如果说有一点难，那我们大概看一下。你就拿着纸，跟你的手比着。什么叫正交？ If my pointer finger is x, what is the angle between the pen to my pointer angle? 同学，你自己右手拿起来，然后左手拿起一支笔，拿这支笔放任意方向。请问你的食指跟这支笔的投影跟夹角怎么找？你可以自己转到你的眼睛看到的是最大角。So what's the angle between the x-axis and the pen? Okay. 同学，这门课不用想，你眼睛看得到这个。So for this coordinate system, visualization is most important. What do you need to think? No need. You only need to do the reorientation. The pen could be very different from my pointer angle direction. But I can turn until the pen and the pointer finger define the surface, and the surface is perpendicular to my eye vision. So this case, this is my theta x. Okay? So likewise, how do you define your projection into the y-axis? Okay, again, get your right hand. Here I define the tongue to be in the z-axis. My pointer finger, my middle finger to be in the y-axis. If my pen is still inclined, I can always rotate until the surface defined by the pointer angle and the pen become perpendicular to my vision. Then this angle is what you call theta z. Okay? 那再来 how do you define the projection to the z-axis? Okay? Still the pen and my pointer finger. 看到没有？那你开始转到哪个面啊？看到没有？你看，如果这是 pointer angle， 那我看到我的掌心了，我的掌心跟这个好像拇指跟这个夹角还没正，形成一个我眼神的这个正交面。那你开始转到它成为正交面，那最大交面。So if you now do the orientation, so why this part is difficult? It's difficult to visualize, but I have to agree. If you look at the formula of projection, it is easy. Okay? So if you are not sure the correctness for this, you can apply this onto my 2D plane.那一般同学对三维的应该比较难想象，那我就用回二维的。It is the same question. So what is the projection onto my x-axis? It is cosine theta x equal to x2 minus x1 divided by the total length. Okay? And then what is my cosine theta y? It is a projection to the y-axis. It is y2 minus y1 divided by n. Of course, from the trigonometry, you know cosine theta y is sine theta. Okay? That is for the ease of writing. Okay? But to be honest, this is just a projection to the y-axis as you did for the 3D space. Okay? So after we have done all this, then we can proceed.这是二维的，这是三维的，就看到没有？它是 x 轴跟这个斜杠之间的夹角。Okay? So you now define what is the cosine theta x, and then next you define the cosine theta z. Okay? And lastly, you define the cosine cosine theta y. Okay, this is how you define okay the 3D truss. 你的正指比跟你的食指、中指、拇指之间的夹子可以转来转去，看你会看得出来。Okay, mathematically, there is one good operation to find the projection. Okay, so you can define the displacement in the x and y and z direction. Okay, this is the displacement of point 1. This is the displacement of point 2. The displacement along the x-axis is u. The displacement along the y-axis is v. The displacement along the z-axis is w. Okay. Now, important point here is if there is a displacement. Okay, you can draw them using this blue box to find the total displacement. But this total displacement can also be projected into respective direction. Okay, how do you do the projection? Take for example, your displacement, u, v, w can be expressed as u prime, y prime, z prime once you do the rotation. 同学，如果说觉得这个很难想象，那我们拿一个盒子。如果这个盒子，这个 x、y、z， 那你定义最长的斜边 ，OK， 最长斜边，那你自己看一下，就从最底部到最顶对面。那你如果这个盒子开始转，OK， 而且是绕着这个长度方向转。Will you change the displacement? Okay. So if you are not able to see this, then let's draw it. Okay, let's use the bi-wing decahedral as an example. Okay. If you are telling me there is a total displacement. This point, it is moving. This point is moving u along the x direction, v along the y direction, and w along the z direction. And finally, you come to reach the point. Okay, when you reach it, you reach the point, something like this. This is the box diagonal. Okay. 好，那现在我们要做投影。OK。你要怎么投 ？OK， 我现在的定义刚才 Now what I define by x, y, and z are parallel to my displacement. Okay. However, it might happen that you want to change the orientation. Okay. One of the things that we will do is I want to find the axial elongation. How do you get the axial elongation? Okay, if I now define axial elongation to be along the length, I should have my rotation. 你看呢？还是拿回刚才比？我现在有一个要求，我的食指 want it to project to the hand direction. Okay? So my right angle, this is my coordinate, all right angle. My x, my y, my z. Okay? It is inclined with respect to the hand direction. But now by rotation, I now have my pointer finger aligned to my pen direction. Okay? So this kind of projection is what you call the cosine rule, okay? Or dot product. Okay, let's see. If you are not familiar with the 3D1, doesn't matter. We start with the 2D1. If this is your L, this is your x2, x1. If you do the projection, this is the unit x-axis. This is my x2 minus x1 is my displacement. Okay? But what I care most is how much is my elongation. If I'm going to find the full stop, what shall I do? What I shall do is I shall have my coordinate rotated so that my x prime come here, y prime come here. This is 2D1. Okay? So you see here? This is my 2D rotation. 你这个转动这个角度，后面是怎么得到？你真的如果转动的话 ，so you can see the projection here. The projection here will give you the unit x-axis. Okay, x cosine theta. Okay, this is x, and then the y. It is also adding plus y. This is sine theta. This is the 2D projection. But any good way you can do the projection. Okay, then we will try to use a dot product. 那我们先用二维的开始讲，然后回过头来再讲我们的三维。OK， 好，那我们看一下，刚才讲的是 x 轴、y 轴，然后它如果转一个60、30度 ，OK， you're going to have your new x prime. What is your new x prime? The new x prime is your ox, and then cosine theta plus your oy sine theta. OK， 那我现在怎么定义我的 x 跟 y 呢 ？OK， 那我有一个可能目标，这个是什么 ？x 跟 y， 那你可以把它写成 OK， 这个是 Now you change the coordinate by rotation. Okay. By rotation of 30 degrees. Now this is your I prime. This is your J prime. Okay. I and J is unit vector. Okay. You can say what is your I here? 来，同学 ，I prime 怎么写？你如果把它当成是圆形的 x y， 那就变成是 I cosine theta plus J sin theta， 可以吧？那你这个写法就跟刚才一样。So if you want to find the projection, okay, now I want to do the projections between this component. Okay, I can do the dot product. I prime dot I is cosine theta. I prime dot J is your sin theta. Okay. 看到没有？现在我们是做向量的内积，我们拿原新的 x 轴的方向跟旧的 x 轴的方向内积，它就叫做 cosine x。那 cosine x 大家可能应该有一点想象，它是 cosine x。那现在呢，新的 x 轴跟旧的 x 轴的内积，它就是 cosine theta y。Okay. So this is the orientation direction change. Okay. So this gives us a very good simplification. Okay, we're talking about the direction cosine. The meaning of direction cosine is very simple. The projection of the old axis in the x direction to the new x direction. This is your dot product represented by cosine theta x. Now if you want to do the projection onto the old y axis, then you got your cosine theta y. Okay? So with this understanding, now we can do the projection of the length. Just some beginner 为最麻烦的，就是空间坐标的转换。你用眼睛看得到，但你是不是要用数学符号来表示？我们还是可以用 sin，但是后面的空间坐标，那我们一律用 cosine。那空间坐标 cosine 的物理意义是什么？就是新的坐标跟旧的坐标之间的投影。So what you can do right now? If I draw this displacement, okay, this is the starting box defining my displacement. Ui, this is my Ui plus Vj plus Wk. If now I'm not happy, why am I not happy? Because I want to find the elongation only. Then I should do the rotation. I should do my rotation of my what's the rotation should I have? If new x-axis is along this length, my rotation is I should first along this plane do the rotation and finally do extra rotation. But anyway, there is a simple direct way of doing the rotation. This is this rotation. That is the shortest distance, your theta x. Okay? by doing this rotation, you will be able to get your new x-axis to be along the length, because we are happy with the axial elongation. If your new x-axis is purely along the rod, then your displacement is your absolute elongation. 所以看到没有？你如果去重新定义，那你现在的 u prime 你把它定义成所谓的杆的轴向，那其他 y v prime 基本上就像你的手指，那你转了一圈。Okay. So what do you do now? If you do that now, you can write your I prime I. Okay, what is your absolute elongation along the axis? If your axis has been chosen that I prime is along the axis, then J prime must be perpendicular to the axis. K prime must be perpendicular to the axis. So then the right hand side gives you the total elongation is equal to the new axis coordinate dot product with O x-axis times U plus new axis coordinate dot product with your O y-axis and then times V, and then finally plus W times the projection from the k-axis to the new x-axis. So in this way, you can find what is the raw elongation. It is u cosine x plus v cosine y plus w cosine z. OK， 所以这个 cosine x y z 啊，不是你正交转出来的，它真的就是刚才我们的那是 b。OK， 那是 b。那跟你的 x 轴 y 轴的最大加减 ，OK， 然后就直接投影过去。So in that way, you can find tip displacement. Okay, what is this elongations on knot 1? It is the projection of horizontal displacement, vertical displacement, and step displacement all onto the new rod axis. Okay? That's why you have your u1 cosine theta x plus v1 cosine theta y plus w cosine theta z. And how about the knot 2 displacement? We can now only the knot 2 elongation along the length direction. Then you have to project your orthogonal displacement in the x, y, z direction all into the length direction. Okay? So this is what you have. u2 cosine theta x plus v2 cosine theta y plus w2 cosine theta z. Okay? So in that way, you can write your elongation along the length. u1 prime is this directional cosine times u1 v1 w1. u2 along the length u2 prime is then the directional cosine times u2 v2 w2. Okay? And in that way, you find out the displacement. And then what's the next step? Because our starting point is very simple. 那请问这支笔是直线还是什么？它是直线。啊，你放水瓶，那我们能解。啊，你放锤子，我们也能解。啊，你放像前头斜一个角度，能不能解？照理也能解，它只是一个坐标的转换。那如果轴向伸长还是伸长？那我们刚才已经讲了，你转向过后，我位移可以通过 directional cosine 去把它投影到这个笔的长度方向。那力的部分呢 ？How about the force? force also the same. Okay, in the description of the force acting on this thing, okay, what's important here is you want to find the axial forces because any rod can only support the axial force. 那就好像你说这是比有比盖，我不懂它哪里去的。比盖能承受什么力？那就走向力。OK， 可以开了。你看垂直方向它会转动。那你现在要找的是轴向力是多少？那你要做的动作是什么？你要把 Fx、Fy、Fc 投影过去。So like what we did for the displacement, the force in the x direction can be projected to the axis. The force in the y direction can be projected to the axis. The force in the z direction can be projected to the axis. So your representation can still be expressed in terms of the dot product of new axis and O axis. So after you have done this, we're still going to write the same rotational, also called the directional transformation matrix. Is the local force means axial force is equal to directional cosine times f1x, f1y, f1z on the north one. And then the axial force on the north two is directional cosine times f2x, f2y, and f2z. Okay. And then let's go back to how to do the transformation. You know the pen and the pen is only can be chained along the length direction. Okay, this is our spring, also called the Hooke's law. Okay, how do you re-express them in 3D? Very simple. Axial elongation is simply transformation matrix times global displacement. This is what you have. But the right hand side, you still got issue. What's the right hand side issue? The right hand side issue is this is still the local force. Okay? What do you do next? If you do the multiplications of the transformation matrix transpose, okay, your right hand side can be transformed into f1x, f1y, f1z, f2x, f2y, f2z. So this whole expansion is then what you call 来，同学看一下，这个转换是怎么来的？刚才我们的转换是这个轴向力跟这个 global force 的关系。那你要让它去做转换 ，OK？ 那你要做转值。Okay, you are not sure what this is, you can do the transformation. The step we are going to do is you are multiplying this with another expression. Okay, thank you. This is the model basics. Oh, okay.这个转制是怎么做的？你如果把这个 transformation matrix 转制 ，OK， 然后再乘，所以 if you now apply both sides with the transpose of the transformation matrix, okay, the left hand side you can do the expression, no problem. The right hand side here is the transpose of the transformation matrix times the original matrix. If you do the expansion, what this expansion is? 它是一个2×6，然后6×2的这个矩阵。那我们先取前三行跟3列。Okay, the important thing here is if you do this, you're going to find that eventually there is only one term being non-zero. This is the diagonal term because of the nature of the ordinarity. Okay. 那后面 ，OK， 有去展开它。Okay. So after you do that transformations, you're going to obtain you're going to retrieve your, what do you have? You're going to retrieve your this f1x when you have the sum of the thing. Okay? And because the right hand side becomes identity matrix, left hand side is the one that you have to do again. Okay, after you do this, then you have this complex stiffness matrix. This is your 3D truss. 那同学可能要回去消化一下，做题的时候就会有感。所以你的右手原理 x 轴 y 轴转来转去，对，转到这个形式，转对了，那就是一个一维；转到3维，它就变成这样。Okay? So there are no difference in describing the log element in 1D, 2D, or 3D. They are still describing the same thing, except the coordinate you described are all different. Okay? So you need some time for digestions. Then let's take a break for 15 minutes, then we'll come back at 3:30.